Question 8. Select the correct answer. The equation beta, you can call it B if you want, B equals 10 log I divided by I sub 0 relates to the sound level. So this tells us what that beta B variable stands for, the sound level in decibels of a noise with an intensity of I. So I represents the intensity to the smallest sound intensity that can be heard by the human ear. So the smallest sound intensity is represented by this, I sub 0. And they give us the exact number for I sub 0. The maximum intensity of a car horn is approximately 0.01 watts per square meter. Based on this information, which value is the closest to the maximum sound level in decibels of a car horn? So we discussed this a little bit already, but we know what I sub 0, it tells us. I sub 0 is 1 times 10 raised to the negative 12 power in this problem. The question wants us to find the maximum sound level in decibels. Well, that means we are finding beta. That's what we're trying to find in this problem. So that must mean they give us I. I is just the noise intensity in this problem. So they give that to us somewhere. Here it is right here. The intensity of a car horn is 0.01. So this is our I value. So let's rewrite this equation. Beta equals 10 times log of, instead of I, it's 0.01 divided by 1 times 10 to the negative 12 power. Now, an important note, at this point, we're going to let the calculator do the heavy lifting. We can do that because almost all calculators have a log button when the base is 10. And remember, when the base is not given, like it wasn't in this problem, there was no subscript right here after the log, it's assumed to be 10. So that means we can just get the calculator out. And this is a graphing calculator, but pretty much any standard calculator, scientific calculator will have this button. So it's 10 times log. And then I'm going to make this a little easier on myself and use alpha y equals number 1 to make a nice neat fraction. Not all calculators will have that. Remember, this is a free calculator. If you just search for this online, you can find something pretty similar to this. Type all this in. Close parenthesis. We end up getting 100 decibels as our answer.